As you guys know, we have an apartment building for apartments, and we're supposed to provide receptacles and lights for these habitable rooms, right? Based on the code and sound engineering judgment. I want to remind you guys, when we do that, we're going to do it based on the code and sound engineering judgment. Sound engineering judgment means if the code does not require it, and it's a good idea to have it, we're going to have it. But at least we're going to meet the code first. Okay, so the code talks intensively, guys, about laying out receptacles in a dwelling. A lot of rules for laying out receptacles. This is basically what this chapter is going to be talking about. So laying out receptacles in the building, lights, as well as circuiting these receptacles and lights. And that's what's going to be our goal for this one. So laying out receptacles and lights and circuiting them. Volt ampere square foot. We'll talk intensively, guys, about load calculation for dwelling units. We will do a load calculation for dwelling units. What I do next week, probably, what I do, guys, I have a sheet for an apartment building that I walk you step by step how to calculate electrical load for an apartment building. So from A to Z, based on the code, with all the code referencing. That's coming. So this is going to be coming. Occupied floor areas of a residence, which one of them calculate. Minimum number of lighting and branch circuits. Really, when we have any building, guys, your designers, when you have any building, you'll be required to lay out your receptacles and circuit these receptacles. You will be required to lay out your lights, circuit your lights. You will be required to circuit all your mechanical equipment. That's all what we do. We have mechanical equipment. Mechanical equipment, we do not lay them out. Typically, they're laid out by the mechanical contractors. Our job is to circuit them. Here's the air handling unit sitting there. I have no say, for the most part, where the air handling unit is going to be sitting. But when the air handling unit sit there, my job is to go disconnect it, provide a disconnect for it, and circuit it. So that's what we're going to be doing. They call it minimum number of branch circuits that you need by the code, and small appliances circuit that I'm going to be talking, again, residential. Layout of the receptacles, where the outlets, lights, and receptacle outlets are going to be located. And we're going to review the NEC code requirement for you. Before we start, guys, with anything else, I want to remind you of the three circuits. If you graduate from Dunwoody without knowing these three circuits, don't go work. Three circuits. Circuit number one is the service entrance circuit. Anybody knows what a service entrance circuit? So if you start with the transformer, here's my XFR, my transformer. The circuit all the way to the switch gear, the power. This circuit is called service entrance. Service entrance circuit, right? Everybody, these are the cables that you're bringing the power to your service, switch gear. The second circuit is coming out of here into another switchboard. Let's just say this was a 4,000 amp. This was a 2,000 amp, right? Doesn't matter what the voltage is. Voltage doesn't matter. This guy is called feeder, right? And then from the feeder, I take 100 amp and go feed Miss Chiller. And this cable is called branch circuit. Branch circuit. Everybody knows these three circuits. Typical, residential, commercial, industrial, you're going to be handling all these circuits. The NEC code book guys talk about them differently. This one, Article 230, Article 215, and Article 210. So that even NEC code book treat them. This will be Article 230. This is 215, and this is 210. So each one of them has its own article that the code treat them separately. Everybody understand how the layout of this system is? So that's basically what a branch circuit. So the code define a branch circuit as from the last overcurrent protection device, which is say 100 amp here, to the utilization equivalent. Here's the overcurrent protection device from here all the way to all the lights and the receptacles. Any question about these three circuits? Everybody's cool with them? There. The middle one is feeders. Feeders, branch circuits, and services. Every building that you guys walk in, it's going to have these three. Cool? So that's what the branch circuit is. Branch circuit from the last overcurrent protection device to the utilization equivalent. Feeder is between a panel to a panel. any panel to any panel, like cold feeder to 15 handlet, and services from the transformer, utility transformer. This is utility transformer. Oops, utility transformer, not any other transformer. Utility transformer. Everybody's okay with this? So we know where we are. Okay, so be aware of that one when we start. Now, what we're going to spend for us in this project, we're going to be basically going to bring. We have an apartment building with a transformer. We're going to bring the power to the apartment building in a meter center, and we're going to distribute the power to every apartment. That will be the feeders. And inside every apartment, we're going to have a branch circuit that goes to all the receptacles and all the lights and all the HVAC equipment. Everybody's okay with this? Understand the big picture? That's what they call it, risers and one-line diagram that we're going to be moving on.
Same process with the motors.
Your motors will be branch circuits.
But well, if you have a set of motors operating the machine, it runs roughly that same way.
Absolutely, absolutely. Here's your motor, the chiller.
Well, I'm just saying, if you have like multiple motors working on like the same system,
Yep.
you have different feeders going to the different motors.
Absolutely, absolutely. So you're absolutely right. All the motors and all the machines that you have is going to be right in this area here. This will have, I'll show you later on, guys, a hospital one-line diagram that has almost 100 panels in the emergency system and emergency system as well as the normal system. So there's so many panels on this area. Down here is your loads. This is very important, guys, as a designer, to understand the flow of energy inside your building. Everybody's okay with this? So how the system is put together. I can't go take a branch circuit from the transformer, right? Everyone understand. You have to go through this sequence.
About different protections at different spots.
Different protection at different spots. Here's the feeder. The feeder is defined basically conductors between two panels. That's your feeder as we draw them. So these are the most important things, guys, you have to keep in mind when you size your conductors. Okay, so now we decided we size our conductors. We know what the feeders, we know what the branch circuit is. Another thing, guys, is ambiguity of the conductors cannot exceed the overcome protection device that protects it. Based on the NEC code book, every feeder, remember the service interest conductors, the feeders and the branch circuits, they are conductors. They need to be protected based on their ambiguity. Based on their ambiguity, let me draw a circuit here, a very simple one. So I have a 20 amp circuit, and this circuit is a branch circuit going to a machine to feed it. So my conductor, based on the NEC code book, have to be number 12, as we know, right? Number 12. The name of this branch circuit, anybody can tell me what does the code call this branch circuit? What's the name of this branch circuit? This is a 20 amp branch circuit. The rating of the branch circuit is the rating of the overcurrent protection device ahead of it. So if this is a 20 amp circuit, this circuit is a 20 amp circuit because of the overcurrent protection device 20 amp circuit. Let me change this one. So suppose I have a voltage drop and I went and I put number 10 here. First of all, can I put number 12 goes with 20, as you guys know. You use 310.15b16, right? We're going to do this one intensively yet. So based on the table 310.15b16, it will tell you number 12 cannot be protected for more than 20 amps. So I have 20 amps tied to number 12 feeding a machine or an equipment. Can I put number 10 and number 12 on the 20 amp? Yes. What's the rating of this circuit? 20 amps. The rating of the circuit is the rating of the overcurrent protection device ahead of it. It doesn't matter what cable you put on it. Now my last example for you, can I put number 14 here? Okay, why no? Because the code says the conductor number 14 is not rated for 20 amps. Number 14 is a small conductor rule. I want to walk you guys through the small conductor rule. Number 14 cannot be protected by more than 15 amps. Exception is motors. Please write this one. And when you go to the commercial, you're going to find a number 14 conductor, and we put a fuse 50 amps ahead of it, and that's okay. Motors are exception. Other than motors, you're going to be stuck with these 20, and number 14 goes with 15 amps. Okay. This is where we said motors are exception. Please highlight this one later on when we start doing motors. Motors are exception to this rule. Any comments, any questions guys about that? I'll tell you what the common circuits that we use in the 20 amps. Okay, as long as we're here, I would like you guys to get used, since we're doing residential, get used to these very, very important branch circuits that we use in the residential. Very, very important branch circuits. If you guys want to use them, the first branch circuit is 15 amp branch circuit. With 15 amp branch circuit, this one always goes number 14, period. So when you put, every time you have a 15 amp branch circuit, the smallest conductor you land on it is number 14, right? If you don't know that by now, exceptions are motors. Later on, please understand. We're going to talk about motors, exceptions. Okay, branch circuit. This branch circuit, typically for lighting branch circuit in dwellings, lighting, we do it 14. The second one is a 20 amp branch circuit. 20 amp branch circuit always goes with number, anybody? 12. Everybody knows the gauge, right? I hope. Gauge, the American wire gauge, number 14 is the minimum you can use. Number 14 is the minimum conductor that you can use for lighting branch circuits and equipment branch circuits. Lighting branch circuit, power branch circuits, and equipment. Everybody's okay with that? Number 14 is your minimum. Every time you have, now when we start circuiting, guys, for me, the apartment building, when you do the takeoff for the apartment, which we're going to be doing, you're going to be doing takeoff. You're going to see a 20 amp circuit, and you're going to take off the cable for it. You have to understand that the cable that goes with the 20 amp branch circuit is number 12. Everybody's understand that? Why it's important for us as designer to understand that? Because you're going to be doing takeoff for this project. Okay, so so these are the most common branch circuit in dwellings. In dwellings, we're talking dwellings here. 30 amp. So let's talk about the second one. My 30 amp is number 10. Please write yourself number 10 is your 30 amp conductor that you're going to be using. Number 10, and we'll talk about where the application is. 40 and 50 is number 8. Number 8. Number 8 conductor is you use typically with 40 circuit breakers. And 50. Let me tell you where the application. So these are the most important common circuit that you're going to be encountering at dwelling. Almost. Any questions guys about these? Any?
You said 10 can go for 20 amps. Does that mean that 8 can go all?
Yes. Yes, absolutely. Can I get you to understand these are minimum? There's one concept confuse the students all the time. When we talk about circuit breakers, we talk about maximum. When we talk about conductors, we always talk minimum conductor. So maximum overcome protection device 15, minimum conductor 14, maximum overcome protection device 20, minimum 12. So can I put a 15 on a 12? Yeah. Remember, can you guys see that? These are min. All these are min. Minimum, these are max. I can't get you guys to understand this from the get-go before we start the commercial. Always overcome protection device, we talk max. Conductors, we talk minimum. What does that mean? I can go higher than the minimum, but I can't go higher than the max. So can I put number 8 on 15 amp? Absolutely. Where would you do a situation like this? Anybody can give me?
Voltage drop.
Voltage drop, thank you.
Long runs.
Absolutely. Long run parking lot. Absolutely. Parking lots, voltage drop, typically outside circuits. That's when we use a bigger conductor on a 15 or a 20 amp circuit. Okay, so these are your circuits. The last thing I would like about these circuits, guys, now remember, we're talking dwelling here. We're not talking commercial yet. Commercial, we'll talk about commercial as we go. Dwelling, where would you use these circuits? Let's just talk about, typically, these circuits are, the 40 and 50 are range. If you have a stand-alone range in a dwelling, you are looking at 40 or 50 amp. Typically 40 amp with number 8. Cool? So you guys have a range in your building. You're going to see, we have a range in our building. So when we do the range, you're going to have a 40 amp circuit breaker from the get-go with number 8. Done. Okay, 30 amp, typically 30 amp goes to two locations. 30 amp goes to air, AC, and also goes to dryer. In a dwelling unit, again, we're talking dwelling. When you see a 30 amp circuit, typically this circuit is going for a dryer or for an air conditioning. The apartment that you guys have an air conditioning, not a window air conditioning. If you have a window air conditioning, you can get away with 20 based on the size. If it's standalone, outside, split unit air conditioning, then you're going to end up with a typical. These are typical, guys. You know, You still need, we do calculation, but typically this is what you do. Okay, the last thing, the last two circuits, these are typically, again, I'm saying typical. This circuit is typically lighting. Lighting circuit and general purpose receptacle. These circuits are special receptacles. Special receptacles, we use a 20 amp circuit, special locations like kitchens and so forth. Can I just get you to understand these four branch circuit that we use in dwelling? When we start laying out the building, that's what you're going to be looking at. Cool? Everybody can see the conductors? Now question number 2 is how many conductors do I need with each one of these circuits? Minimum. Can anybody tell me a minimum how many conductors do I need? Minimum. We need 2. The ground is always goes without discussion. The ground, we don't count it. When we say conductors, the ground goes without discussion. We need 2 conductors. So for this circuit, you need 2. Anybody can tell me why? Hot, neutral. How about this circuit? 2, typically hot, neutral. How about number 10? 2, typically the 30 amp for air conditioning or dryers. Typically, we have 2 conductors with a grounding conductor, of course. With the ranges, they use 4 conductors. Anybody knows why 4? They have 2 hots and a neutral and a ground. So in this case, since we're not counting the ground, that will be what? 3 plus the ground. All of them plus G plus the ground. All of them plus the ground. Any comments, guys? Any questions? From the get-go, do we understand the branch circuit that we use in a residential building? Commercial building, good luck. You're going to be doing calculate. We'll talk about commercial when it comes. Any comments, any questions about this? So when I say the air conditioning, the rating of the circuit for the air conditioning is 30 amps. The rating of the air conditioning for the rating of the circuit for the range is 40 amps or 50 amps. Okay, so that's, can I get you guys to understand these circuits? Very, very important circuit. That's what you guys are going to be circuiting for me in this apartment. A branch, all these are branch circuit. Have I forgot to mention that everything that I drew here are branch circuit? They're not feeders, they're not service conductors, they are branch circuits in this case.
Is there going to be a separate AC for each apartment, or is it in one?
We're going to have, based on that, we have a separate AC for each apartment. Separate AC for each apartment. Okay, there's one table, since you guys Minnesotans, that everybody knows 94, Interstate 94. Okay, Twin Cities. If I say the Twin Cities in Minnesota, everybody knows where the Twin Cities is. Now, this table is as common in the electrical industry as the Twin Cities to the people who live in Minnesota. Okay, so if you don't know it, don't even get into this industry. Okay, this table is called this. She got married lately and changed her name because she got married. 310.15B16. 310.15B16 is one of the most important tables that you're going to encounter in your career as electrical designer. That's where you're going to spend probably 80% of your time sizing conductors with me and in the field. With me in the field, we will digest that baby from A to Z for commercial, industrial, and we will go to other cables. So 310.15B16. This is where you're going to size all your conductors. We also typically these conductors are when we size conductors, guys, they size them based on 3 factors. Very important 3 factors. Factor number 1 is the temperature rating of the insulation. Is it THHN, THW? Is it rated for 75 or is it rated for 90? That's the temperature rating of the insulation. Factor number 2 is the size. What size? Is it 1/0, number 1, number 12? And factor number 3 that we use for sizing it is the ambient temperature. What's the ambient temperature in the area? Is it 30 as it should be, or is it 50 Celsius? 30 or 50. So these are 3 factors that are very important when you size a conductor. And then there's other auxiliary factors. Do you want to use copper or aluminum? Right? You have to decide, are you using copper conductor or aluminum conductors? And then the last factor, so that will make them 5, is are you grouping these conductors together in one conduit, or are you sending them in cables separate, no more than 3 current conductors? So we will get into this next chapter, and I'm going to leave hashing these table until next chapter on Monday. We're going to go to 3.16 and we're going to, I want to walk you guys right through the table, how to use the table from now until you graduate from here. So then when we use the table, there's some derating based on temperature derating and carrying conductors. And they group them, they're no longer at the bottom of the tables. They group them, actually they're not at the bottom, they group them in a standalone table. And again, we will be looking at the derating table based on temperature. What does derating table means? I have a conductor that can carry 50 amps because I grouped it with another troublemakers, another 5 conductors that are also hot. They will interact and they will heat each other up, right? So I have to derate it. Otherwise, it will be heating up more and it will fail. That's one derating. The other one derating, I have a conductor that rated for 30 degrees Celsius based on the table. I decided to put it in the middle of a desert in Arizona and the temperature is 55. So what do you think is going to happen to the conductor? It's going to heat. Can I get you to understand, guys, from the get-go? I keep saying it. Enemy number 1 of electricity is heat. Get this in your mind. Enemy number 1 of electricity is what? Heat. If you can cool the conductor, I can make number 14 conductor. If I can cool it, I can make it carry 50 amps, 100 amps. Because it heats up. When it heats up, it fails. The insulation will fail. So if you can, that's why heat is a big deal. We derate all the time. Enemy number 1 is heat. That's why the electrical utilities, why do you think they send all these transmission line overhead? They're naturally cooled, right? They're not trapped. They don't trap the heat. So that's it. Keep in mind, because of all this heat, we're going to be derating based on ambient temperature. And I know you guys did, right? We did a little bit of this table, but I would like to walk you through it one more time for both the commercial, industrial, and the residential. So keep this in mind for that. The rating factors, 310.15b. This is the table that we're going to go again next week. We'll get into this table based on installation single raceway. This is based on grouping them. So we derate based on temperature and based on what they call a grouping. If you have more than 3 hots in one conduit, you have to derate. We're going to do that. And if you have more than, if you have other than 30 degrees Celsius, we have to do it. And again, I want you to hold the whole calculation until next week because chapter 4 talks in details about this. General lighting and receptacle. Now let's go back to the loads. Let's go back to the dwelling. I want to remind you guys, if we're doing a commercial building, we don't even think of a 15 amp branch circuit. Get it out. 20 amp is your minimum. It's not worth putting a number 14 in a building like Dunwoody. It's not worth it. Number 15 amp branch circuit. 20 amp is your minimum for branch circuits, receptacles, and lights. Just keep this in mind. Now go back to dwelling. We're doing dwelling. Dwelling, people don't do a whole lot of dwelling, right? In dwelling, it's not like the light goes on 8 hours a day. So we treat them slightly differently. So for your general lighting, they call it general lighting and general purpose receptacle. Almost always what we use is 15 amp branch circuit. And knowing what you guys know, and we don't use a 20 amp circuit unless you're my brother-in-law that wired all his house with 20 amp circuit. Can I wire the whole house with number 12 with 20 amp circuit? If you ask me personally, I would say it's overkill. I know some people do it. You don't 20 amp circuit needed in certain application. You're going to see them. 20 amp branch circuit in dwelling needed in certain application. In all other applications, 15, number 14 is good enough for you. No question asked. So general lighting and general purpose receptacle, they call them general purpose receptacle. General purpose, can you guys get to the term? These two terms, they use them a lot. They're general use receptacle, general purpose receptacle, and general lighting. These are, you're looking at 15 amp branch circuit. For example, I have a bedroom, and I'm putting all my receptacles in the bedroom and the lights. I can grab my receptacles and my lights and put them on at 15 amp branch circuits, and we call it general purpose lighting and receptacles. So 15 amps. Can I put a 20 amp? Yes. If you ask my judgment, it's overkill, personally. When we do load calculation, guys, we're going to be looking at this table. And again, I promise you, we're going back to this table because we're going to do load calculation. When we do load calculation, the NEC code book for general purpose receptacles and lights allow you 3 volt amp per square foot. For example, I have a house that's 5,000 square foot house, big house, 5,000 square foot. For only the general purpose receptacles and the lights. 5,000 multiplied by 3, that will give you 15,000 volt amp. This is the allowance that you're going to consume for your lights, and general purpose receptacles. Lights and general purpose receptacles. Again, I promise you that we will do intensive calculation with this number when we do the load calculation coming. Cool? But just be aware. And where does this number 3 coming from? It's going to be coming from this table. And this table, we're going to use it 3 times. We're going to use it for residential, commercial, and industrial projects. So we're coming to it. So that's your... there is a term called continuous loads. Let me define a continuous... The code defines a continuous load, guys, in Article 800. They define it as a load that's... A lot of people don't understand that. The maximum that goes for 3 hours or more, here's the key point, and it has to be the maximum current. Can you guys highlight this one? The most maximum current. So if I have a machine, the machine consumes 10 amps, and it runs for 3 hours, but it runs at 5 amps. That's not a continuous load. I have a machine that takes 10 amps, full rated amp, and it runs for 2.5 hours. It's not continuous load. The question would be, who cares, Chad, if it's continuous load or not? Who cares if it's continuous load or not? If it's continuous load, 2 very important things has to happen. If your load is continuous, 2 very important things have to happen. Number 1, if you guys, dwelling is not continuous load. Dwelling is assumed, the light and the receptacles and the equipment are assumed for dwelling is non-continuous load. We move it to the commercial, we start talking continuous load, everything. We size everything based on continuous load. So keep this in mind. So what the continuous load would do to you? Take this. If I have, when we size a load, just give you a very good idea. So I have, let's start with a branch circuit. I have a 20 amp branch circuit, okay? And I want to put at the end of it a machine, and I can't, if I can't get you guys to understand that one, I have an overcome protection device. I have to put a machine. My circuit breaker is 20 amps, and it's continuous load. What's the largest load can I put on a 20 amp continuous? Circuit breakers are not rated for continuous load. If you run continuous load, which is, we know what a continuous load is, 3 hours or more, you have to cut the rating of the circuit breaker by 80%. So what is 80% of 20? So the answer would be, Chad, is going to be 80.8 times 20, and that will give you 16 amps. That's it. So no matter what, your load cannot be more than 16 amps. Done. So, and my conductor here is still number 12. My conductor here is still number 12, but I can't pull more than 16 amps out of it. Can I get thumbs up that we understand that, Chad? Cool. Now, so this is if it's continuous load. So that's for starting with this one. Now, take another example. Here is a load. Oops. Here's my load, and I have a load right here. And let's just say my load is let's just say at 21 amps load, continuous. And I want to go put a circuit breaker on it and a conductor. Continuous. I know this is not almost getting into the commercial industrial. I have 21 amp continuous load. It's going to carry for 3 hours. How do you size a conductor for it? See, first, if you have a circuit, you cut it by 80%. If you have a conductor, you have to multiply the load by 1.25, up it 25%. Okay? So here's what you're going to do. This is how we size it, no problem. You take the load, 21, multiply it by 1.25. Anybody can give me the math calculator? What's 21 times 1.25?
26.25.
26.25.3 amps. 26.3 amps. Cool. What's my next standard overcome protection device?
30.
My next is 30. Great. So my next is 30. See how now my overcome protection device is 30 amps. Do you see how it makes a big difference if it's continuous load? Now, well, I need to size the cable, right? Okay. You size the cable again, 26.3A. Can you guys go to 310.16, 310.15B16 and find me a conductor that can carry this? Cable 310.15 16B16, and I know this will be page 154. 154. Can you guys give me a conductor that can carry it 26.3? We go to column 60. We default to column 60, always 60 column. What's the conductor size? Huh? Thank you. Number 10. The conductor is number 10. Number 10. Number 10. Any question guys about that? Do you see the difference for continuous load? Number 10. Number 10. So that's where a continuous load make a big difference. If you have a circuit breaker, you derate 50% and you find the load. If you have a load, you multiply 25% to find the conductor and the overconduction device. This calc that we did in this side, we're going to be doing it a lot when it comes to the commercial and industrial. That's how we're going to be sizing your continuous load. Any comments, guys, about continuous load? Everybody understand that concept of continuous load? Just to give you an idea, let's just say the load here was not continuous, right? How much current can I pull out of this 20 amp circuit non-continuous? Non-continuous. 20 amps. I can put a 20 amp load non-continuous on that, and if you check,
Load?
yes,
So a 20 amp load on a 20 amp breaker?
on a 20, non-continuous.
Yeah, but you don't want to load your circuit over 8%.
Non-continuous. I don't want to defend it even. I completely understand. I don't want to defend it. I don't do it. But non-continuous.
Okay.
Non-continuous. Now, for example, when you start doing the receptacles for the dwelling, non-continuous, you can almost load the circuit if it's 20 amps up to 20 amps. They're not running at the same time. Okay. If this is non-continuous, guys, if this is non-continuous, again, we assume guys everything is continuous. That's why, like, this is what we do. Now the only place you're going to encounter non-continuous in dwellings, and dwellings is already set. So if this was a non-continuous, you don't do the calculation. So a 21 amp circuit, what's the conductor to carry 21 amp circuit? It's still number 10 based on 21. You don't do the math here, 21. What's the next overconduction device? 25 amp. So I could put 25 amp, it's still number 10. So it didn't make a difference in this case. So you don't do the 1.25 if it's non-continuous. Now let me put the disclaimer. Remember, I'm an engineer. 99% of the time, the loads that we design for hospitals and all this building is considered continuous load, and we use the 1.25 all the time for safety. Okay, so that's your continuous load. Okay, so there's voltage differences, guys. There's something called nominal voltage. I want to highlight the nominal voltage. One nominal voltage, because we're doing dwelling. If you're doing a dwelling in the US, your options are two options, 99% of the time, if you're doing dwelling. Option number one, voltage-wise, and they call it the nominal voltage. The nominal voltage for dwelling is you're using 240/120 volt single phase. Here's option number one. That will cover all your single and multi-family dwellings to a certain value. Now you get into apartments, risers, 5, 10, 20-story building risers, apartments. 240/120 does not have enough energy and juice in it to get you this what you need. So then you up into a three-phase system. So this is option one. Option number two is 208/120 three-phase. That's another typical application that you're going to use voltage nominals for your systems. Any comments, guys, about these two voltages that we use for commercial, for residential? 240/120 single phase or 208/120 three-phase. We call them nominal voltage because they're name only. They don't go up or down. They're name only. I'm not sure about this number here. I put a question mark on that one. Fluctuation. Your voltage typically fluctuates, guys, 5 to 10%. Allowed to fluctuate 5 to 10%. So when you go measure the actual voltage in your building, you're going to find 10% higher or 10% lower than this, the actual voltage. So, any comments, guys, about these? The only place you're going to use this one typically as in dwelling as apartments. Oops. We're going to use it for apartments. Any question about this? Everybody knows what the two voltages that we use? Do we use 48277? Rarely, if ever. We're talking dwelling here. Any comments about the voltages, the nominal voltages that we use? Though the NEC code book lists a bunch of other voltages, 48277, 240 delta, 3-phase, 600 volt, and a bunch of others, up to 600 volt. We'll talk about the actual voltages at a different time. Now we're concerned about two voltages that we're going to be using. Any comments, guys? Any questions about that? These two voltages? I'm going to refer the calculation, guys, based on this into a different things. We're going to be doing calculation based on Article 220 for the whole apartment, so I'm not going to mess with the calculation this time. When you do the calculation, though, you take the square foot of the building and you measure from the outside parameters. Only the habitable places are included, or any space that's adaptable for habitable habitable space. So unfinished basement, you count it because you could finish the basement. The portion that could be finished for habitable, that should count. Now I don't like to split hair. Garage, you would never remodel your garage to make it a living room. Could it happen? Typically, non-habitable spaces, you don't count. Your porch, don't count them. Spaces in your basement that you have your mechanical equipment, you're not going to go put your bed right next to the air handling, to the air conditioning or the, what do you call it, the furnace. These areas are not, you don't count them. Everything else, garage does not count, sheds and so forth. So we'll talk about the calculation, guys, that we do based on square foot of that building. So the way we do calculation, again, we're going to do the calculation. You take the square foot of the building, measure it from the outside, multiply it by 3 volt amp. But which area you do, can I get you guys to understand that habitable space, like bedrooms, living rooms, hallways, kitchen, laundry, and so you take the square foot of that area, the habitable space, multiply it by 3, and that'll get you the volt amp for your building. We're going to do intensive calculation on that one. You deduct anything that does not include, like porch is deducted, garage does not count, unfinished basement, the portion that you cannot modify, typically the mechanical equipment area where you put your air conditioning, does not count. Okay, so that you get, to get your branch circuit, general purpose branch circuit, then you divide it by 120, and that will get you how many 20 amps, 15 amp circuits you need. Divided by 120 volt, and then you divide by 15 amps, and that will get you, so first you multiply the square foot of the building by 3, then you divide by 120, right? Then you divide again by 15, and that will get you the number of branch circuits that you need for this dwelling building. I don't like to do it this way, the branch circuit. I'll give you guys a couple of rules when we do the calculation for a branch circuit. Any comments, any questions about that? Comments, questions? If you have a track light, if your house has a track light, the track light is actually part of the 3 volt amp in a dwelling. In non-dwelling, you have to add 3 volt amp per, you have to add 150, I think, 150 volt amp per foot of that track light.
Yeah, you said you put these boxes up on.
I will make sure they put all of them today. Remind me before I leave. Keep forgetting. Yes. So here's the square feet, guys. Your 3 square foot. If you have it, can I get you just to understand, based on the code, the track light is included in this 3 volt amp. You can't exceed what the track light is rated for, though. Okay, let's talk about branch circuits now. For branch circuit, can I give you guys 5 minutes to refresh? Because I need to talk about branch circuits, or the branch circuits, the dedicated branch circuits first, and then the general branch circuits. Should we have 5 minutes? Get you to move your stuff.
So like that. that one was a typo, that's 65%.
Yeah, I
The
don't.
book says 5.
5, yep, yep. That's completely. That's what I said. It's usually 10%. The book says 5, right? Okay. That's what I thought, Friday. Okay, let's just talk a little bit about branch circuits. Branch circuits. When it comes to, let me go directly into here. We're talking in dwelling, so I would like you guys to remember in branch circuits there are 4 types of branch circuits. So you remember that one. 20 amp branch circuits. In the kitchen, here's what you're going to be doing. Required by code, the 20 amp circuit, if you want to write yourself a note. And oh, by the way, who asked me about the PowerPoint? They are on the network now. The PowerPoint. You need 2 for the kitchen. You call it 2 small appliance branch circuits. Write yourself a note. You need 2 20 amp branch circuits for the kitchen. They must go through the countertop. So here's your 2 for the kitchen. And also can feed, with these 2 20 amp circuit can feed the breakfast area. You need 1 for the bathroom. You need 1 circuit for the bathroom here, 2 for the kitchen. That's required by code. You need 1 for the laundry. So how many 20 amp circuits we need so far? 2 for the kitchen, required. These are required, not recommended, required. 2 20 amp small appliances circuit for the kitchen, 1 for the bathroom 20 amp, and 1 for the laundry. Any other 20 amp circuits required? Required, not recommended.
No, that's it.
Not required. Good idea, but not required. Here's what you're gonna be working on. These are basically the required branch circuits. Required 20 amp. I'm not saying 15 amp. Required. Another 20 amp that also goes. Typically, we give 20 amp circuit if you want to write yourself a note. If you have garbage disposal and 2 dish washer. These are highly recommended. Highly recommended. You have a garbage disposal, dishwasher. Typically, we put them in a 220 amp circuits. We feed 1 from this circuit, 1 from the other circuit. Recommended. Can't emphasize. Recommended. Yes, sir.
Microwave.
Thank you. We're coming to another one. 1, 2, 3. Microwave. These are the ones that also recommended. Highly recommended microwave as you put it on a 20 amp circuit. Are we missing anything else? Sump pump. If you have a sump pump, 1, 2, 3, 4. 1, 2, 3, 4. Sump pump. If you have a sump pump, highly recommended. Actually, you have to. Sump pump is dedicated load. You have to put it in a 20 amp circuit. Any question, guys, for your apartment? For the apartment that we have, this is the 20 amp circuit that you're going to be going. Should we go over it one more time? 2 for the kitchen, 1 for the laundry, 1 for the bathroom. I'll give you 4 required by code. The rest of them, highly recommended. Garage door, garbage disposal, dishwasher, microwave, and sump pump. Can you guys get yourself a note that these are the 20 amp circuit? These are the ones when you start branch circuit them. That's what you're going to come a branch circuit right now. You're going to branch circuit these as a 20 amp circuits. Cool? Any question about the 20 amp circuits that you need in the kitchen? So how many? We have 4 required by code and another 4 highly recommended. Are we missing anything? That's typical dwelling.
Sometimes they do the refrigerator.
Refrigerator is recommended on a 15 amp branch circuits. I typically feed it from the 220 amp circuits personally.
The breakfast area includes like
The breakfast area, now let me talk about the 220 amp circuits for the kitchen that can feed the receptacles in the dining room or breakfast area.
Don't you need one of any flow over 2 feet or island?
We're talking receptacles now. Here, we're talking here branch circuits. Yeah, there are 2 things, guys. There's the receptacle layout is one thing, and the circuits is another thing. We're talking about branch circuits, meaning how many 20 amp circuits of this type. Here's my 20 amp circuits, and then right here, we'll talk about how many receptacles you're going to feed from them. You know, we're talking about branch circuits. Okay? So here's your 20 amp circuits. Any question about the 20 amp circuits? These are dedicated 20 amp circuits for these type of appliances. One thing I want you guys to understand, by code, the 220 amp kitchen circuit, can we feed light from it? No, they are sacred cow, shall not be touched by anything other than receptacles. Sacred cow. Bathroom circuit. Bathroom circuit also is a sacred cow for the receptacle, though you can feed the light in the bathroom from it and the fan. If you have a fan, bathroom, 20 amp circuit in the bathroom, you can feed the GFCI receptacle as well as the light and the fan. Laundry circuit is also a dedicated circuit. These are these 1, 2, 3, 4 dedicated for that particular receptacles. Any question, guys, about these circuits?
The garbage disposal dishwasher usually on the same 20 amp circuit?
Personally, I put them in 220 amp circuits. So one for the garbage disposal, one the dishwasher, one microwave, one sump pump. Any question, guys, please write yourself a note. That's when you lay out your circuits in the building that we have. That's how you're going to lay out your circuits. Okay, 15. How about 15 amp branch circuits? Now, 15 amp branch circuits, all other receptacles that's not listed in these areas, and also all other lights, all other lights in the area, all other lights. They're going to be 15, 20, 15 circuits, 15 amps. Any question, guys, about that? Do we know now how to circuit these babies? Okay, now I'm going to add one more circuit here that we talked about. We have 30 amp circuit. This will be AC. If you guys want to write yourself a note, we have an AC, going to put 30 amp for a circuit. We also have another circuit, 40 amp circuit. This is going to be range. We have a range. These are another two dedicated. These are called dedicated circuits for appliances. Dedicated circuits. Dryers. We have a dryer too. Another circuit, 30 amp. We have a dryer. Typically, this is what you're going to be doing in a kitchen, in a dwelling, dryer. These are all the branch circuit they're going to have in this apartment building, for every apartment, almost. Washing machine is part of the laundry room, right? The laundry room. You have a 20 amp circuit for the laundry room. Though for this apartment, guys, we have a washing machine for the whole apartment. So what we do, because it's an apartment, we give every washing machine a dedicated 20 amp circuit. Just because it's an apartment that we have, I think we have 2 washing machines in the laundry area. You're going to give each one of these a 20 amp circuit because it's an apartment. Yes, sir.
You're only using a 30 amp dryer because it's electric dryer. So
yes. If your gas dryer, thank you. If you have a gas dryer, you can plug it in from the circuit that's feed the laundry room. Any question, guys, about the circuits? This is it. You're looking at how you're going to circuit the whole building. Yes, sir.
MW and SP stand.
Microwave, sump pump. Sorry. Microwave and sump pump.
No, not all.
That's a big deal. Any question, guys? Everybody can give me a thumbs up, Chad. We know what the branch circuits in the whole apartment now. It's going to be. These are your branch circuits. You will have an extra branch circuits we talk about, guys, later on, because we have a swimming pool. We have dedicated circuits for the swimming pool. One for the light, one for the receptacles, and one for the pump. We have a pump, and we'll have a heater. And these will give them bam, 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 dedicated circuits. Okay. Now, is it wrong to put all your other receptacles on the 20 amp circuits? No. Is it overkilling? Yes. You have a receptacle in the bathroom, in the kitchen, not in the kitchen, in the bedroom, and put them all in a 20 amp circuit. You can. In my book, it's a little bit overkilling. So that's your branch circuits. That's your these are your branch circuits. We'll talk about. This is what they call them, and if anybody wants to, this is where the code refers to these as small appliances branch circuit, guys. And when we do the calculation, we're talking about circuits now, but when we do the load calculation for the whole apartment building, they allocate a 1500 volt amp for every circuit. 2 of them will be 3000. That's based on the code. We'll talk about this one later too. So these are you, and these are kids. Sacred cow shall not feed anything. Nothing but the receptacles in the kitchen and the dining room. Cool? You like the sacred cow, don't you? Okay, receptacle and lights, minimum requirements. There's a couple of, okay, now we'll talk about, so any question about the branch circuits and the circuiting? Kinda? Clear a little bit? Okay, now let's talk about laying out receptacles. Now we know how to circuit them. Now we need to go lay out our receptacles. when we lay out our receptacle, I want you guys to write these two very simple rules. I call them rules of laying out receptacles. Rule number one, if you want to write it down, it's called 6 by 12. And rule number two, it's called 2 by 4. Two rules, 6 by 12 and 2 by 4. Very easy. 2 by 4 is easy to remember, 2 by 4. 6 by 12, every habitable room defined as bedrooms, living rooms, kitchens, playrooms, what else? Dining room. All these habitable rooms, you apply the rule 6/12. What's the 6/12? You grab the edge of the door, you measure 6 feet, you put the first receptacle, you measure 12 feet, you put the second receptacle, 12 feet the second, 12, 12, 12, 12, all the way to the end. When you reach, suppose that this is a door, when I reach the other end, another door, make sure I'm not further than 6 feet away from the other door. Everybody understand that rule? And you grid your 15 or 20 amp receptacles. Typically 15, but you can put 15 or 20 amp receptacles. Any question about this rule? This is for habitable. This one is habitable. We'll find out how to spell that. Habitable rule. That's it. 6 by 12. The second rule, Aaron, does it make sense, the 6 by 12? From the edge of the door, you measure 6 feet, one receptacle, 12 feet between them, 12 feet, 12 feet. When you reach the other end of the door, make sure you're not further than 6 feet. If you are, stick another receptacle. 2 by 4, this is kitchen countertop. By the way, does the 6 by 12 apply to the kitchen too? Walls, yes. The walls of the kitchen, not the countertop. The 6 by 12 applies to the walls of the kitchen. So when you have a kitchen, you're going to apply the rule 6 by 12 to the walls of the kitchen, as well as everything else. 2 by 4 is countertop. Countertop for kitchen. The kitchen countertop. Everybody knows a countertop of a kitchen, right? Countertop of a kitchen, you start from one edge of the countertop, measure, it's 2 by 4. 2 feet, put receptacle, then 4 feet, 4 feet, 4 feet. Here's the sink. Make sure you're not further than 2 feet away from the sink. Done.
Yeah, I thought you started at the sink and then 2 feet down.
Either way. Well, either way, you're going to balance them. You guys are designers, so you're not going to stick to 2 feet. So you're going to kind of use this as a guide and go a little bit more. I mean, if you're very close, stick one receptacle. These are guidelines, bare minimum. Any questions about these two rules? Can I have a thumbs up? We fully understand these rules? Okay, so these are really the rules of laying out receptacles. So rule 1, 2. Rule number 3. So we have bathroom. How many receptacles do we need in the bathroom? One receptacle, right? Rule number 4. Laundry. You need one receptacle for the laundry. Okay. Rule number 5. You have basement, unfinished basement, one receptacle. Unfinished basement, one receptacle. Unfinished basement. 5, 6. Outdoor. You need 2 receptacles. Outdoor 2 receptacles. One in the front of the house and one on the back of the house. Cool? Everybody knows that. The rules by code. 2 receptacles. Garage. Attached garage. 7. Garage. 1 receptacle. You need 1 receptacle for Mr. Garage. 1 receptacle. Did we forget anything else? Balcony or deck. Balcony or deck. Number 8. Balcony or deck. Let's say deck is easier. Deck is going to be 1 receptacle. If I know how to spell that one. Any question, guys? Balconies or deck is going to be 1 receptacle. Unfinished basement. Unfinished basement. Not business. Did you say business? Unfinished basement, 1 receptacle. Okay, let's go over it one more time. First, you're going to go the rule 6 by 12. Easy. We know how to apply for all the habitable spaces. Unfinished basement is not one of them. 2 by 4 for the countertop. Then we start laying these receptacles. We have a bathroom. You have to have 1. Laundry 1. unfinished basement one. If we have outdoor, you need two, one in the front, one in the back. Garage, you need one. If you have a deck or balcony, you need one for each.
That's just minimum.
Thank you. That's a minimum. That's a minimum. Yes, sir.
Well, would this be like single family dwellings? Because like if we're doing this 4-unit apartment.
Thank you.
how
Now we're
many-
doing an apartment. What's the difference between an apartment? Everything here applies for families and dwelling. Everything that we listed except one little thing. Anybody can pinpoint? We have a garage. Everything applies. The only thing that does not apply is right here.
That sounds like-
Outdoor receptacles. Outdoor receptacles, apartments don't own their outdoor, right? Typically, the people in the apartment don't own outdoors. So what they do is, the code says, if you have an apartment building, and if you have one of the units in the apartment that opens directly to the outdoor, you have a door directly, not through the common space, directly you have a door, the sliding door, and gets to the outside, you have to have a receptacle.
On the ground level? Or?
Of course, on the ground level, yeah. To the outdoor and the ground level. So you're going to see our apartment that we have, guys. When you look at it, there's two apartments at the bottom. They have direct door that opens to the outside. You're going to put the receptacle, and you're going to feed this receptacle from that particular apartment.
That kind of goes with number 8, decks and patios.
Yes, almost. Now, these are the bare minimum. I'm asking you guys for the apartment building actually to provide receptacles in the front and the back. That's engineered. Remember, sound engineering judgment for the holidays and so forth. So I'm asking you, when you see the requirement, to put receptacles, common receptacles in the front and the back for holidays and parties and so forth. Any questions guys about this? Any questions?
So then, does it end up getting charged to a particular apartment then?
When we get into our apartment, we're going to have a common panel or house panel, they call it. And that common panel is going to feed all the common lights in the hallways, all the common receptacles, including the outside receptacles, the swimming pool. We have a swimming pool. We have also I can't remember, I think the laundry, we put the laundry as pay laundry, charged to the common. So these are where you're going to get and pick and what's common and what's not common.
But each apartment's going to be metered separately.
Yes, we have five apartments plus a common panel. We're going to have 5 meters, one for each apartment and one for the common panel. We'll get into that one, guys, as you get into it too. Any comments, any questions? So this is really the big picture. With the big picture, there's a few little pictures that I want you guys to, before we move forward, let's talk about GFCI, as long as we're in it. All these receptacles, let's use a color, which color? Blue. Talk about GFCI. Okay, do I need 6 by, how about countertop kitchen? Does need to be GFCI? GFCI. Countertop must be GFCI. How about bathroom? GFCI. How about laundry? Laundry, if it's within 6 feet of a sink, GFCI. So I'm going to put question mark here. If you put the receptacle within 6 feet of the laundry sink, it has to be GFCI. If there's a laundry sink and you put the receptacle within 6 feet of the laundry sinks, have to be GFCI. Cool? Okay, let's talk about unfinished basement. GFCI. Let's talk about outdoor. Of course, yeah, GFCI.
You need one for an unfinished basement?
Yes, at least one receptacle for unfinished basement. Garage door. Garage. GFCI?
Yeah.
GFCI, thank you. Deck.
Yeah.
Deck area, GFCI. GFCI.
Or don't you?
Thank you. Good point. Where don't you need a GFCI? 6 by 12. Bedrooms, hallways, living rooms, dining rooms. Help me here. Any other similar rooms? Playroom, gun room. If you're like my brother-in-law, and you have a room for guns. Not kidding. Gun rooms.
Protecting against like water, let's say.
Yeah.
Well, why would you need an unfinished basement then?
Dampness. GFCI guys are required in 2 locations. If you're in doubt, always any damp location or any wet location, you're talking about GFCI. If you're in doubt, okay. Any question guys about the GFCI? We got the GFCI. All right. As long as we're on it, We'll talk about the EFC in a second here. Okay, now there's a tiny little rules, Aaron, that we use. Okay, now you have a wall in a habitable room, and that wall is 2 feet or more. I call it the 2-foot rule. A wall, just tiny little wall between 2 doors and 2 feet or more, you need 1 receptacle. Can you guys write yourself a note? In any habitable space, you need 1 receptacle. In the countertop, if you have a space of 12 inches or more, you need 1 receptacle. Again, this is the countertop, and this is a habitable space. Everybody's okay with that? These kind of tiny little rules. A wall of 2 feet or more, 1 receptacle. That's where a designer become a good guy or gal. Now, what if you have 1.5 foot, guys, in an area where it's really isolated? Would you put the receptacle? Yes, I would, as a design project. You're going to look at the apartment, and you're going to see in our apartment there's an area, like in this area, and there are doors all over, and it's less than 2 feet. And if you look at the closest receptacle, it's going to be like 9 feet away from you. Do you really want somebody? So it's a good idea to put, even if it's less than 2 feet. The code says 2 feet. Ask me, we are engineers, we go a little bit higher than the code. So if you have a tiny little space, you put a 2 feet in it. Okay, any question about these 2 tiny little rules? Okay, so we got the receptacles. Here's how your kitchen, guys, is going to go. Remember the rule, you're going to start from right in here, 2 feet. What do you guys think is going to be here? 4 feet. Measure around 4 feet. This must be what? 2 feet. 2 feet. This one, 4 feet. This one from here to here, 2 feet. Or less. You guys know how we measure around the corners, right? Peninsula, 1 by 2 peninsula, like this needles, if you have a receptacle 1 by 2 feet or more, you need 1 receptacle. An island or a peninsula. Like these, you need 1 receptacle. Okay, wet bar. If you put a receptacle on a wet bar, guys, if this receptacle is within 6 feet, what do you think this receptacle is going to be? GFCI. Anything within 6 feet of a wet bar is GFCI. Any question about laying out these receptacles? You guys are going to have the same countertop. You're going to lay out the receptacle. These are easy. This is a 2 by 4 rule. 2 by 4 rule here. This one is if it's 2 by 1, 2 feet by 1 feet, 1 receptacle. 2 by 1 or more, 1 receptacle. This area, guys. Suppose this is a 1 foot here, 1 foot space right here. Can you see that? 1 foot space. What do you need to do? 1 receptacle. 6 inches. It's up to you. 1 foot or more, 1 receptacle. Any question, guys, about laying out the receptacle? Now, Aaron, when you get these are guidelines. You don't want to go minimum. Don't get splitting hair and measure exactly. So if you have to add another receptacle, do it. Now remember, we're designers and engineers, guys. We don't go by the minimum, right? But what I hate to see put 5 receptacles in this little area here. You don't want to overkill.
So unless your garbage disposal is hardwired, you throw a GFCI.
Ah, thank you. No, the GFCIs are on the countertop. Below the countertop, no GFCI required. Garbage disposal, dishwasher. You have a garbage. Do we have, like, say we have a garbage disposal dishwasher underneath here? Non-GFCI because you're under the countertop. The circuit breaker for the microwave. You have microwave high, no GFCI for it. Only the countertop ones. Okay, so we got the receptacle layout. Receptacle lining outlets. We talked about the sinks. Automatic closed dryers draws a large amount. We talked about the dryers have GFCI. Unfinished basement, we talked about this. 1 in the front, 1 in the back. When you have not apartment, when you have a house, you need a receptacle in the front and a receptacle in the back. A receptacle in the front and a receptacle in the back of a house. If it's an apartment, only required if 1 unit opens directly to the ground level. Then you have 1. Am I clear about this? So so we got that one clarified. Balcony and deck. Remember we talked about the balcony and deck. How many you need? At least one. At least one. The receptacles, guys, can be receptacle single or multi-receptacles. Typically what we use is the duplex receptacles like these. But you can use also single receptacle, one yoke. One yoke, two yoke, one receptacle on one yoke, two receptacles on two yokes. Typically this is the one that 99% of the time we're going to be using. Okay, any comments, guys? Any questions before we go into the last one which talks about lights? Any question about laying out receptacles? How many receptacles in the bathroom? One receptacle. If there's some requirement in the bathroom receptacle, you have to put it within what? 3 feet of the sink. Within 3 feet of the sink. Yes.
Like a printout sheet or something that has all the kind of standards.
All the rules, I can make one for you. I don't have one, you know. Yeah, absolutely.
But yeah, it'd probably be something like
Easier.
Word program.
Absolutely. Absolutely. Good idea. You're going to see, yeah, because if you're not familiar with them, it's confusing a little bit. You're absolutely.
Yeah, so the memorize.
Yeah. Absolutely. Okay. So the last thing I want to talk about, guys, in this chapter, if you guys, if I can get your attention here for one little second, we talk about the receptacle. Yeah, one more receptacle we forgot to talk about. HVAC equipment need maintenance, so they require you to put a receptacle within 25 feet of every HVAC equipment, air handling unit. In our case, it's going to be the only one that we're going to have is what? You're going to have an air conditioning outside. So remember, outside in the back, what do we have in the back? We have a receptacle required by the code in a house to be there. So if you have the receptacle there, then you don't have to adhere to it. So one receptacle can do two functions. One of them is to be the outside receptacle in the back, and at the same time, a maintenance receptacle for the air conditioning. So, but remember, when we do commercial, if you have a rooftop units, or if you have a chiller, cooling tower, so forth, any of these mechanical, you require to put a 2015 or 20 amp receptacle. Usually we dedicate a circuit to them for maintenance. Okay?
So you only do that 20 amp for the outside?
So
You're going to put up one of the air conditioners out there?
no, this is just for maintenance, to maintaining them, not to power them.
Not to power, okay.
No, not to maintain. So you're working on them, and you want to plug in an extension cord so you can work on them. Yeah, not to power them. To power them, 30 amps. We talked about the branch circuit, 30 amps to power them. Okay? Let's talk about lights. Now, we talked about receptacle, all these by code. This is really one of the nicest summary of all the lights. Okay, required. Every habitable space requires a light. Why? Because we don't want the people to trim, right? So look at this. I have a bedroom. You need at least one light. Hallway, one light. All bedrooms. Any utility room. Stairways, all these are required lights, basically. In the attic, do I need an attic? If you have an accessible attic and you store things there, you need a light. If you have an attic that you have mechanical equipment, like an air conditioning or something there, you need a light. If you have non-accessible attic, you don't need to mess with it. Cool? A light. With the light come a switch. Your switch can be wall-mounted or on the luminaires, typically wall-mounted. So these, I can't emphasize, guys, if you look at this, this will summarize all the placement. So in the basement, I need a light. I need utility room. All these locations require a light, as you can see. The garage, the outdoor, can you guys see the outdoor light? I need an outdoor light for the service door as well as the garage. So these are required lights that you have to provide them. These lights can be switched. The outdoor light can be switched or an occupancy sensor. Anything outdoor, you can put an occupancy sensor, motion detector, or switched. So you probably know all this. I mean, it's not. The only thing I want to emphasize, if you have a stairway, if you have to have a light. The light could be right at the top of the stairway, right next to the stairway, it doesn't matter. But if you have 6 steps or more, you're required to provide a switch at the top of the stairway and another switch at the bottom of the stairway. You're supposed to provide a switch at the top, a switch at the bottom, only, Aaron, if you have 6 steps or more. Now, if you have 5 steps, would you provide it or not? That's a different story. But 6 steps or more, don't split hair. 5 steps, what one? It's easier, convenience. One the top of the bottom. Can I get you guys, and this is written somewhere here, where it says, in bedrooms,
So
yes.
then if you have the double one, you use one at each spot if they're more than 6 steps each one.
If you have just a landing, you don't have a door, you don't need it.
But if there's a door, then you do.
Yes. So like in this case, we came here, from the top, we came here. You need one, these are 2 stairways almost. One here, right? And then one here, one here. But if that's just up, landing, and down, you only need them at the bottom and the top. You don't need them at the landing unless there is a door that takes you somewhere else. Make sense?
The house I grew up in, if you come in the main door, you come into a landing, you got 2 steps.
Well, there's a split level.
Oh, then these becomes 2. If you come to a landing, they're treated.
Front door comes onto a landing, you go to the steps.
Yep, these are 2 stairways, exactly like this. Like if you're coming from here, 1 stairway, treat it, another stairway. Make sense? Just treat them as 2. Okay. What? Oh, better plug. Oh, what did you guys do today? It's a Friday. I forgot my battery. All right, no, don't die on me, please. Okay. All right. Any question, guys, about these? Any question about these? Now, one little thing. Whom am I going to pick up? Joe, my friend. One little thing. In other than the kitchen, let me ask you this question. Can I have a switched receptacles as a lighting outlet in a kitchen? Switched receptacle. Can I use this switched receptacle as a lighting outlet? Yes. In dwelling? Yes. Can you use it in a kitchen? No. In a bathroom? No. Laundry? No. Can I use it in a bedroom?
Yep.
Yes. Hallways? Yes. Living room? Yes. I hate them though, personally. But the kitchen and a bathroom and laundry, you don't want to have. You can't have a switch receptacle as your lighting outlet. You understand what I mean? Instead of having light there, you plugged in light into an outlet, and you switch the outlet.
There's nothing worse than buying a house that doesn't have any ceiling lights.
I hate that. I mean, I put mine. Mine has the same thing. Yeah, but you can. So a switched outlet can act as your lighting outlet, except in the kitchen and the bathroom and laundry. Okay, any questions about these? Typically, this picture, please refer to this picture as you lay out your lights. Now, these are the bare minimum. Darren, my friend, now, would I go more than that? Like, you need one light in the kitchen. Would I put a couple of cans in the kitchen to make it look nice? Yeah, especially if it's my house. If it's your house and you're not paying for, you're paying bare minimum, probably I would just surface mounted fixtures, 15 amp and call it a day. $15 and yeah. Cabinet lights, you can put cabinet lights.
Cheapest 2x4 fluorescent.
Or the 2x4 fluorescent lights. For the apartment building, guys, you're gonna understand people don't spend a whole lot of money on apartments. So you're gonna make something good, but not, not outstanding. Okay, so this is, guys, the last thing I want to talk about, apartment buildings. Can I talk one little thing? I know it's Friday. So any question about the lights, please review this sheet. It really, where's Aaron? Aaron, this summarizes all where you need the lights, really in one picture by the code. Now we have an apartment. Let's talk about apartment. I have my apartments. Why do I have a delay here? And let's just say here, and here, and here. And you guys gonna use your imagination with your friend Chad. There's a door here, and there's a door for this apartment here, here, and here, and here. Okay? So this is apartment 1, 2, 3, 4. I have 4 apartments, and I designed it this way. And these apartments are like you do, 4 apartments, and yes, sir.
Did you say that the PowerPoint was available?
Yep.
What is it under?
Yeah, can you show them? So this area is a common area. This is all common area. Now the code and the building code is very clear about the common areas in an apartment. If I can get your attention, guys, you can't feed anything in the common area from anybody's apartment. Everything in the common area must be fed from other than the apartment power system. So all the lights in this common area, all the receptacles, if any, anything coming have to be fed from a common panel. Can I get you guys to understand that? So that's very, very clear. That's it. That's the only thing I want to mention. If you have an apartment like the common spaces, hallways, anything common, laundry laundry areas coming in apartments, receptacles that's coming in common areas, and lights, garage door opener, if it's, door opener for the whole apartment, all these have to be fed from a separate panel other than the tenant's panel. Cool? Everybody's okay with that one? So that's what I want to mention, just in case about the apartments. That's why in the quads, if you remember the way the engineers do them and the architects, they make the quads. Every apartment has its own entrance. Have you been in a quadruplex where the apartment has its own entrance? So there's nothing coming between them, really, nothing. No hallways coming between them. Maybe the laundry area is the only place that's coming there, and then they feed this one from the house. That's it. So to avoid having anything coming. So all the lights they're going to be installing in these areas and the receptacles have to be two things: powered and controlled from in a public place, and powered from a public panel. The last thing I forgot to mention. I keep saying the last thing. Arc fault circuit interrupter. Arc fault circuit interrupter. Please add this one. Now, arc fault circuit interrupter, required since we in Minnesota adopted 2011. I want you guys to remember, arc fault circuit interrupter applies to the following: to receptacles and lights. Can you guys write yourself receptacles and lights? In everywhere in the apartment, except, I'm going to write the exception because it's easier to write the exception. Cool? Everything except any place that, just to give you a hint, any place that has a Gfci receptacle. Remember, the area that has a Gfci does not need EFCI. Okay, let's remember that. Which one need a Gfci in an apartment? Kitchen, one of them. Light and receptacle, no EFCI. Another place, bathroom. A third place, outside, unfinished basement, laundry, garage. All these locations does not require the arc fault circuit interrupter. Everything else, receptacles and light, required arc fault circuit interrupter. Now Aaron is looking at me and said, "What the heck are you talking about, Chad?" I'm talking about a difference between $7 circuit breaker and $40 circuit breaker. So that's the difference. That's why that's
It's freaking brutal when you gotta fill the whole panel.
yeah. That's the difference. The difference is, do I need a $7 circuit breaker or do I need a $40 circuit breaker? That's the difference between an arc fault circuit interrupter circuit breaker and none. Now, in terms of dollar-wise, that's why I just want to get your attention for dollar-wise. Now, in terms of safety, arc fault circuit interrupter is supposed to monitor the circuit, everything in the circuit, the branch circuit as well as the devices. If it sees any arc, phase to phase, phase to ground, or between the phase, there's a break in the phase and it arcs, they call it series or parallel arc, series inside the line that's going in, parallel between a line and another line. It watches it and it monitors the signature of this arc, and it will trip. It has an electronic circuit that analyzes that little signal that looks weird, and it will trip the circuit breaker up on the existence of the arc, because they discovered, the smarter than Chad, that a lot of fires are blamed on, rightfully or non-rightfully sometimes, blamed on electrical arcs. Yes?
That light in the attic, do you typically just run that from a different circuit?
No. No.
On attic circuit?
All the lights are mixed up. You can group them together and feed them. No, not a dedicated circuit.
So then that one would be
Yes, yeah. The challenge is, now take this. What if you have the light? Now remember, the kitchen lighting have to be fed from a different circuit, right? So now you have a lighting circuit that feed the bedroom and also the kitchen. Now the kitchen lights are on an arc fault circuit interrupter, right? By default. So, but does it need to be? The question is, does it need to be? No. Any question, guys? Most of them end up being on an arc fault anyway, just by default. Any question about arc fault? Yes.
So now you just always assume the attic is possibly going to be used for storage? And
No, no.
required light?
No.
Okay.
No. Unless you have a permanent means of getting into the attic, stairway that fold down, a stairway that goes up to it. There are some, if you don't use it for storage, like as a permanent means, I know some people use it, but permanent means. Now that's what the code says. Now ask me my opinion. If you put a ladder and you use your attic for storage, should you put a light? Absolutely. Now remember, guys, we're designers. We're gonna make it safer for people to use their homes, right? So should I put one even if I don't have a permanent means of going up? Absolutely. If I'm using it as storage. When I say storage, guys, you're putting, there's a lot of insulation there, so you're gonna put something to hold, store things, and so especially in Minnesota, to use it as a storage, really you have to do a lot of things. You have to seal, you have to put insulation on the roof, right underneath the roof. Otherwise, you can't just store right at the top of the insulation. Would you?
Well, you could throw some plywood down and just be cold storage. A lot of people do that. Store Christmas stuff up there and whatnot.
Above the insulation?
Yeah.
Okay.
Well, if you have bats, that's a big difference.
Yeah.
Obviously, if you have blowing, that's not going to work.
Yeah.
My house has bad insulation. But it's
Yeah. See, mine is have a blown insulation. You can't find it if you put it there. Yeah. I guess it depends what type of insulation. You're right. No, that doesn't qualify. Okay. Any questions? Any questions? Any comments about the arc fault circuit interrupters? What's the difference? $7 to $40. That's a big difference. Okay, so hopefully that, guys, will give you an idea as we hit next week. Jeff, we're going to hit the circuiting the power, laying out receptacles, and circuiting. Can you guys give me a thumbs up, Chad? We know how to circuit with the Gfci, and so we're going to lay out the receptacles next week and circuit them and assign a 20 amp circuit or 15 amp circuit or 30 amp circuit or 40 amp circuit to the circuits, as well as laying them out and decide which one Gfci, which AFCI. Okay. Don't forget that in dwelling, guys, all receptacles must be tamper proof, right? These are, you've seen the tamper proof where you have to push both slots in order to get into the energy there. Tamper all receptacles dwelling apartment must be tamper proof, 15, 20 amp, 15 and 20 though, 15 and 20, 120. If you have 40 amp, 50 amp, no. And if they're outside, they have to also be, anybody remember what? Weatherproof. So that's when that doesn't mean anything, Aaron, right now, except when we start doing takeoff. When we do takeoff on this apartment, you're going to have weatherproof, Gfci, tamper-proof receptacle. It runs you $21. Okay? Cool? Is this enough, guys, to get you kind of... I know you have seen this before, most of you, but that's probably will be the first and last time you hear Chad talk about residential before we roll into commercial industrial. Okay, so that's all we have for you guys today. We'll continue with the AutoCAD, and thank you, guys. Yes, if you VPN. You have a VPN? You don't know how to VPN?
I don't even know what that means.
VPN is just a button that they give you access to our network. So go to the IT and let them, I'll look at your machine if it has, go search in that little search with VPN and see if you have it. It might be installed in your machine. Otherwise, talk to the IT, they'll VPN you.
What would you do if you were like riding the bus and some dude just get out? Like you gotta go out there and
Is it disabled? Yeah, because you're done with it now.